Hello everyone, welcome back to the Pharmacy India students. So as you all know that we have started the new series for MRB Tamil Nadu Pharmacist, in which we have observed around 425 pharmacist vacancies. So with new day, we are going to start with new topic of the pharmaceutics, and today we are going to discuss the best questions of tablet dosage form. So what is tablet? Before starting, we will look into a short introduction. Tablet is a solid unit dosage form which is made with a compression or with or without diluent. So we will discuss best questions based on the previous years of the pharmacist exam and some model questions also based on this topic. Now before moving on to the first question, I just given a little short introduction about the Pharmacy India app. So if you are a pharma student or if you are a D Pharm or B Pharm student, so you have you should have Pharmacy India mobile app in your mobile phone, because in this mobile app you will get latest update regarding the pharma exams, competitive exams. Now moving on to that, now you can also visit on our website pharmacyindia.co.in for the official updates of regarding various exams, and you can join our WhatsApp and Telegram group. Link is given in description below. Now moving on, before moving, now first question on our screen is, in designing an orally ingested tablet for modified release, which feature of film coating is most critical? Means while you are designing orally ingested tablet, means the tablet which are going to be ingested orally, via orally. So what we have to consider as an special feature, increasing the tablet weight, we have to increase the tablet weight, or masking the test without affecting drug release kinetic, or providing a barrier to moisture and controlling the release profile, or enhancing the tablet's color for marketing purpose. So what it means, providing a barrier to moisture and controlling the release profile means you have to give a coating through which we can protect from the moisture. Yes, we can we can mainly protect the tablet from the moisture. So there are different types of coating. If we will look into that, there is a single type of coating, that is seal coating. And what is the function of the seal coating is to prevent the moisture penetration. Okay, so film coating can serve multiple roles, but for modified release formulation, the key function is to control the drug release profile, and the film provide as a barrier to moisture and gastrointestinal fluids. Now moving on to the next question, which type of tablet is most suitable when a drug requires separation of incompatible ingredients in a single dosage form? Means which type of tablet we will make when different types of ingredients are incompatible with each other. Let's suppose if we are having a two types of ingredient X and Y, and they both are incompatible, so which type of tablet we should prefer for that? Compressed tablet, multiple compressed tablet, film coated tablet, or sugar coated tablet? So the correct answer is that is a multiple compressed tablet. By doing the multiple compression, we will make like if I'm taking an example, like if we are having a X and Y ingredient and we have to, they both are incompatible with each other. So what we can do, first we will compress the X itself, and after that Y, and after that we will make again by doing, and we will make like this. So it will considered as a multiple compressed tablet. So now moving on to the next question, in formulating chewable tablet, which excipient is most critical to ensure palatability and acceptable mouth feel? Means while you are formulating the chewable tablet, what is chewable tablet? In which no disintegrating agent is required. So what we will use, microcrystalline cellulose, lactose, mannitol, or talc? So I will give you the answer, that is mannitol. Mannitol is used in chewable tablet due to its negative heat of solution. Yes, it will provide the mainly soothing effect due to its negative heat of solution. Due to its negative heat of solution. Yes, due to its negative heat of solution. Negative heat. Okay. Now if I'm talking about next point is, in chewable tablet no disintegrating agent is used. 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 Yes. Now moving on to the next question, that is, when preparing an enteric coated tablet, which property of the coating polymer is essential? Enteric means that will be for, especially for intestine. Yes, ENT means, ENT denotes intestine. Intestine. So high water solubility at all pH level, or insolubility in gastric pH but solubility in intestinal pH, strong adhesive properties irrespective of pH, or ability to form a thick or opaque layer. What is the correct answer? So let me clear, when we are having a enteric coated tablet or enteric coated polymer, it means the tablet is meant for the intestine, not for the gastric environment. So it totally tells you that it should be insoluble at gastric pH and soluble at intestinal pH. So the correct answer is, and if I am taking an example of mainly enteric coated polymer, yes, there are mainly high chances to ask the question from this, that what is the example of enteric coated polymer? Enteric coated polymer. Enteric coated polymer. Enteric coated polymer examples are, that is, phthalates, means like cellulose acetate phthalate. Those names which are ending with the phthalate word are known as enteric coated polymers. Yes. So there are so many examples, that is cellulose acetate phthalate, HPMC hydroxypropyl methyl cellulose phthalate. So these are the enteric coated polymer. Now moving on to the next question, which of the following tablet types is designed specifically for absorption through the oral mucosa bypassing first pass metabolism? Means which type of tablet is meant for oral mucosa and will bypass first pass metabolism. What is first pass metabolism? First pass metabolism is a phenomenon of drug metabolism. Like let's suppose if we will have a 100% drug and we administered 100% drug through the tablet, but by reaching at the site of absorption it reach around 60%. So what about 40%? 40% itself will metabolize by liver gut wall. So that is the first pass metabolism. But mainly we have to tell that which type of tablet is for oral mucosa and will bypass, means this will bypass. So what is the answer is, that is buccal and sublingual tablet. As you have many time observed that while someone is having a panic attack, so what we administer, what we will give, that is your sublingual tablet. By giving the sublingual tablet, they will bypass the first pass metabolism, and because of high capillaries available from the sublingual route, the drug automatically reaches into the systemic circulation directly. Okay. Now the next question is, in wet granulation, why is the selection an appropriate binder PVP or HPMC critical? In wet granulation is a type of granulation technique. There are three types of granulation: dry, direct and wet. So wet is the another technique. So what the question asks, in wet granulation, why is the selection of the an appropriate binder is critical? Because it influences granule size. Yes, it influences granule size, mechanical strength and drug release profile. Mainly granule size can be affected and the release profile can also be affected by this. That's why it is critical. Now moving on to the next question, dry granulation by roller compaction is favored when the drug is heat sensitive or a liquid binder is required, the formulation contains volatile solvents, or the powder has excellent flow property. So which is the correct answer? That is the drug is heat sensitive. Yes, dry granulation by roller compaction is favored when the drug is thermolabile, means the drug can be degraded with the heat. So we can use the drug, mainly we will use the roller compaction in case of when drug is heat sensitive. Okay, dry granulation particularly by roller compaction is ideal for heat sensitive drug. Now the next question is, which excipient category primarily enhances tablet flowability or powder flowability and prevents sticking during compression. Means the question asks which excipient. So let me clear, that is lubricant. What lubricant does? Lubricant reduces the friction. Lubricant reduces the friction. Reduces the friction. Reduces the friction. Reduces the friction between. Reduces the friction between tablet and dye wall. Tablet and dye wall. So you can also learn with a trick, that is LTD. LTD, T for tablet and D for dye. So, and there is a one important term is also that is a glidant. Glidant works as a flow promoter. Glidant works as an flow promoter. Glidant works as an flow promoter through which we can promote our flow. Now the next question is, microcrystalline cellulose is frequently used as a diluent because why we are using microcrystalline cellulose as a diluent? Because of it improves compressibility and provides robust tablet hardness. Robust tablet. Microcrystalline cellulose works. Microcrystalline cellulose. The other name of microcrystalline cellulose is your avicell. It is known with the name of. Avicell. Yes, the trade name of microcrystalline cellulose is avicell. So the correct answer is, it improves compressibility and provides robust tablet hardness. Okay. Now next question is, during tablet compression, what is the primary cause of capping? What do you understand by capping? Capping means, let me clear, when the partial separation, when the tablet divided into two parts, partial separation, or the upper part or the crown of the tablet will separate it from the main body or lower part of that. That is capping due to the air entrapment. This is a tablet related defect. So inadequate binding between granulin and leading to a weak tablet structure. Means like when tablet crown or lower part will get detached from the main body. That is capping. And there is a word also, there is a one defect which is very important, that is lamination. What do you understand by lamination? In lamination, the tablet will divide into 2 to 3 more layers. 2 to 3 more layers. That is lamination. Okay. Now, moving on to the next question. In multiple compressed tablet, what is the advantage of using a compression coated design over a simple layer tablet? Let me clear. In multiple compressed tablet, what is the advantage? Here, the question is asked from the advantage part of using a compression coated design over a simple layered tablet. That is it simplifies manufacturing by reducing processing steps. Let me clear, if we are having a mainly reduction in processing step, so automatically the price of that particular formulation will get reduced because the processing cost will get reduced. The processing, if the time get reduced, then processing cost will get reduced automatically. The patient will get benefited. So this is the major adverse effect. Compression coated tablets allow the separation of incompatible active or ingredients with different release profiles. The outer coating can be engineered to provide delayed or modified release, while the core provides immediate release, offering precise control. Okay. Now moving to the 11th question of today's class, that is that in multiple compressed tablet, what is the advantage of using a compression coated design over a simple layer tablet? So in this question, the advantage is asked. So it simplifies manufacturing by reducing processing step, or it allows a separation of active ingredient that require distinct release profile, or it reduces the overall tablet size significantly, or it is easier to administer orally. So in this question, what actually asked is that in multiple compressed tablet, what is actually we are doing different other than other than simple layer tablet. So in multiple compressed tablet, we are making different layers of different drugs, so we can allow the separation of active ingredient that require the distinct release profile. Means this particular drug layer will release in 1 hour, and the second upper than this it will release in 3rd hour. So this is all about this question. Now the next question is, which lubricant is most commonly used in tablet formulation due to its effectiveness at low concentration despite its potential for over lubrication if not carefully controlled? Options are calcium stearate, option B is polyethylene glycol, option C is magnesium stearate, option D is sodium lauryl sulfate. So let me clear what is the function of lubricant is. Lubricant is reducing the friction. Yes, the main function of lubricant is to reduce friction, yes. Now there is a single word, that is sodium lauryl sulfate. Sodium lauryl sulfate will act as an surfactant. Question may be asked from this point, so you please write it down. Sodium lauryl sulfate is your surfactant, and surfactant means which reduce the surface tension and interfacial tension. Let me clear one more point about SLS is, that is sodium lauryl sulfate having the HLB value, is all about 40, near 40. So the correct answer is magnesium stearate is the lubricant which reduce the friction. Now next question is, how does a glidant such as colloidal silica improve tablet production? Means in this point the glidant role is asked. So what is glidant? Glidant is nothing, it is your flow promoter. It will work as an flow promoter. Yes. And colloidal silica derivative, like there are 3 examples under the colloidal silica, that is your carbosyl, aerosyl and siloid. These 3 are colloidal silica derivative, and the answer is by reducing interparticle friction the glidant will work. Glidant is just nothing, it is a flow promoter. Now coming on to the next question, during dry granulation by slugging, what is the primary challenge that must be managed? Means in this question, the question asked all about that while you are doing dry granulation, so what would be the major challenge you will face during this process? Overwetting, or variability in slug size, or excessive binder evaporation, or formation of an orderly. That is variability in slug size. Slug is nothing when we will just make a powder collectively like a compact mass, that is your slug. Variability means keeps on changing, that is it must be managed. Okay, now coming on to the next question, which property of lactose as a diluent is particularly beneficial when used in direct compression formulation? Options are high moisture content, excellent flowability and compressibility, its inherent sweet taste, or its ability to act as binder. So the question asks, so which property of lactose, means we have to tell the property of lactose. Let me clear one important point about lactose is that is your, it shows Maillard reaction with amine containing drug. It shows amine containing drug. Amine drug means which drug is having amine group. So it shows Maillard reaction. It is very important. Maillard reaction. Okay. Maillard reaction. Now, so the correct answer is excellent flowability and compressibility. The mainly lactose excellent flowability and compressibility will make lactose more famous for the direct compression tablet. Now coming on to the next question, in tablet manufacturing, what is the primary function of disintegrant? what is the main function of disintegrant? What is the role? Let me very clear. There are two types of disintegrant, and what actually disintegrant is? Disintegrant is doing the breakup of the tablet, which facilitate the breakup of tablet, which facilitate the breakup of tablet, facilitate the breakup of tablet, facilitate the breakup means the tablet turns or breaks into the particle with the help of disintegrant. So the correct answer is to promote rapid breakup of the tablet. And let me clear, there is a super disintegrant also. Super disintegrant, and super disintegrant will work more efficiently and more speedily in comparison to the disintegrant. And I'm just giving you the example of the super disintegrant, that is Avicel. Avicel is your super disintegrant. And the Primogel is also work as your super disintegrant. So this is the mainly examples of super disintegrant. Now coming on to the next question, that which of the following is the potential consequence of using an excessively high concentration of soluble lubricant? Means when you are using more than the limit of the lubricant, so what will happen? Improved tablet hardness, or reduced dissolution rate due to hydrophobic coating, or altered drug release profile and potential interference with disintegration, or enhanced stability of the active ingredient. So it will mainly alter the drug release profile, means it will change if you will use excessive, excessively, if you will the more amount of lubricant, so it will alter the release profile. And there's a one question also I have just mainly arised in my mind, that the dissolution rate. Which equation govern the dissolution rate? Rate of dissolution. The rate of dissolution will govern by, rate of dissolution is governed by Noyes-Whitney equation. Noyes-Whitney equation. Okay. Now coming on to the next question. Is, in a wet granulation process, why is it important to control the amount of granulating fluid? Means in wet granulation we are using the granulating fluid to make the granulation, or to make the wet granulation process to be completed. So why is it important to control? Means why we are not using the more amount of the granulating fluid? Why it is important to control that amount? To maximize tablet size, or to avoid overwetting, or to increase the density, or to ensure a uniform color? As it's simple, means if you will add more liquid in something, then it will get overweight means the water is not get absorbed properly, so it will get overweight, which can lead to agglomeration, means the lumps will be formed. Okay. Now coming on to the next question, what is the primary function of a buffer sodium bicarbonate in tablet formulation? To maintain pH and to enhance the stability of acid or base sensitive drug, or to serve as a disintegrant, to provide color, or to act as a filler? Whenever the question asked from the buffer, so the correct answer is, buffer is used in any formulation to maintain its pH, okay, to maintain the pH of the formulation. That is the correct answer. Now to maintain the pH, and disintegrant, which facilitate the breakup, to provide color, that is the coloring agents will use to provide the color. Now moving on to the next question, in the context of a tablet compression, what is most likely to cause lamination? I have discussed earlier that what actually is lamination. Lamination is separation of layers into two or more layers, separation of a tablet into two or more layers, means the tablet will get separate like this. Okay, so the correct answer, inadequate intergranular bonding and trapped air during compression will cause the lamination. In this question, the main reason of lamination is asked. Okay, now coming on to the next question, which compression machine is best suited for small scale production and rapid formulation development? Means which compression machine we are using or best suited for small scale production and rapid formulation development? Dryer quota, multi-station, single punch tablet machine or roller compaction machine? That is your single punch tablet machine is used for the compression mainly, which is best for small scale production. Now, moving on to the next question, what is the key advantage of using multi-station rotatory press in high speed tablet production? Means what is the key advantage? In this point, the advantage is asked of multi-station. It is also kind of machine which we are using for the production in tablet. So they produce tablet within the unique shape, or they enable continuous and high volume compression with consistent tablet weight and hardness, or they require manual intervention for each tablet, or they are less expensive than single punch machine. What actually the point is asked? So mainly the advantage of multi-station is that they are enable continuous and high volume compression with consistent tablet weight. Means the tablet weight will be uniform, and the hardness. The point is asked all about the hardness. So let me clear. The average hardness of the tablet is 4 kg. 4 kg. Many a time the question asked from this point. Now coming on to the next question. Which type of tooling is typically used for producing complex tablet shapes and patterns? Means which type of tooling? So the correct answer is D tooling we are using for producing complex tablet shapes and patterns. Okay. Detooling is employed when the tablet design requires intricate shapes or detailed impressions. Okay. Now, the next question is, in tablet manufacturing, what is the function of anti-adhesive such as colloidal silica? Means again the question is asked from the formulation part. Means in tablet manufacturing, what is the function of anti-adhesive? It will act as a binder to prevent the tablet from sticking to the punches and dyes during compression, or to enhance tablet dissolution, or to provide a glossy finish on the tablet surface. What actually it is all about? That is to prevent the tablet from sticking to the punches and dyeing during compression. That is the correct answer. Anti-adhesives like colloidal silica will reduce the friction between tablet formulation and the tooling surfaces. Now, the last question of today's class is a tablet which exhibits mottling. Mottling means unequal distribution of color. Which of the following mostly likely cause? Means mottling reason is asked in the question. Overuse of lubricant? No, it is not related to the lubricant. Excessive compression force? No. Inappropriate granulation method or inadequate mixing of colorant? Yes. Uneven distribution of color means when the mainly substance is not mixed properly, so there is uneven or unequal distribution will take place. So ultimately the process or the term is known as mottling. So the correct answer is option D. So now I hope you mainly we have connected and we have cleared all the questions related to this subject. And now if you are preparing for MRB, then I just recommend you the MRB objective book for your competitive exam preparation. So it will give you more confidence, and we will meet in the next video. Till then, Jai Hind, Jai Bharat.